Hello and welcome to episode 4 in the Delphi Training Series brought to you by 3dbuzz.com. My name's Buzz.
And I'm Logan.
And before we get started, I'd like to take just a moment and point out that the high-res version of this video will be made available in the next couple of days. You'll be able to find the link to this version on the YouTube site located to the right of this video, as long as, of course, you're watching this video right now on the YouTube site. Now, we understand that the quality is poor, and that's not our fault. Unfortunately, we have to encode the video at a much smaller size to be accepted by YouTube, and obviously all of the text gets, well, shredded when you do that. So we will make the high-res version available in the next couple of days. Now, in this episode, what we're going to do is take a look at variables, what they are, how to set some simple variables up, and to use variables. Now, we have, in an essence, used variables so far in the flea game, but we did it in a very roundabout way, right, Logan?
Right. There was a convenient property attached to some of the controls we were using, and that was able to store numbers, which was useful to us, and things like levels and score.
He said the key thing, store. That's right, you're going to find yourself needing to store information, or let's just start calling it data, while writing applications, and you store this information in variables. And since we hadn't taught variables yet, we kind of cheated. We used the tag property that was available. Actually, it's available on most objects that you create when doing a VCL application in Delphi. So anyways, we use that to store our information, but we're going to go back by the end of this video and clean it up so that we're not using the tag property. We're truly going to be using variables. It's going to make the code much cleaner, right?
That's right. More cleaner, more professional.
Exactly. Now, I've promised you guys that we're going to write an application in each of these videos. And we're going to. But here's the deal. This time around, it kind of got out of control. The application I want to write is going to deal with sound. Because as we work our way to writing more interesting and complex games, we're going to need to get sound added in. And I'd like for you guys to be able to go back and add sound into your flea game. Well, to do that, I was trying to think what kind of application would be cool to write. And the one that we've decided to put together for you guys ended up becoming quite sophisticated. As a matter of fact, it's nearly 3 times the length of flea, right, Logan?
Yeah, it's 3 or 4. I mean, I don't remember.
Yeah, maybe even 4 times. It's big.
It was a test version that we actually checked before. So
exactly. So it ended up being really big. The problem with this is that we would then end up recording, a 5-6 hour long video teaching everything we needed to in order to get that application written. And that's just really not acceptable. What's going to happen is we're going to end up with a file size too large for YouTube to accept, and then it just wouldn't work out. So I've decided to break these down into a series of smaller videos. And like I said a second ago, this video is going to focus on just variables. But I wanted you guys to know that what's going to happen, this video, the next video, and the video after, they're all geared towards the creation of this application. Now, what is this application? Well, you guys are going to write your very own MP3 player. And here it is right now. No, it's not Winamp, but it does have some pretty nice features. And funny enough, it's compatible with Winamp. How cool is that? We are going to show you guys how you can go above and beyond the things that we've put together so far. We're going to show you how you can actually go out and get a third-party sound library and use that in your application. And we're doing that as opposed to using what's built into Windows for the simple fact that you're going to have so much more control easily, which is going to put you guys in a really nice spot when we start writing more complex, what's the word I want to use here?
More complex sound systems.
Yeah, sound systems in our games, exactly.
The MP3 player only scratches the surface on what Base is fully capable of.
Right, and Base is going to be the sound library that we're going to use. So we're going to completely walk you guys through how to get it off the internet, how to get it set up in your application, and then how to make use of it. So right here, this MP3 player is going to, of course, utilize that third-party sound library. We're also going to get into some file manipulation so that you guys can start saving out things like game settings or high scores or whatever type of information you'd like to write out to a file. In this particular case, we are storing out our playlists. And these playlists are M3Us. They're compatible with Winamp's playlist. So you can load a Winamp playlist in. Or if you save a playlist out, you can go over into Winamp and load that playlist up over there, right?
Right. It's compatible. It will properly parse the M3U file so that it only grabs the pieces it can use. As in, it doesn't use extended information or comments or titles or anything. It just pulls the files out of the M3U.
Well, the goal is we want to keep this as simple as possible. Now, we've taken it just a tad bit further than Winamp in a sense, And I like to play guitar, right? I'm not a professional or anything. It's just a way that I like to kick back in the evenings and kind of relax. And when learning, more complex songs, one of the things I like to be able to do is take the song and slow it down while I'm working with a complex riff, just to practice it over and over. And we've given that ability in this MP3 player. As a matter of fact, as we get time, we're going to go back and add several things into this that will allow some nice features for musicians that play guitar, keyboards, etc., to help them in learning songs. So in this particular one, let me reach over here and grab a mouse, steal that away from Logan. Down here at the bottom, we actually have the ability to control the tempo, which is pretty cool, and I'll show you guys that in just a minute. Kind of a quick tour around the user interface that you're going to be creating. Up here, it's just going to simply list out whatever song is playing at the moment. Right now, we're not playing anything. Over here, we've got our simple transport controls. Down here, we have a slider that we can use to manipulate our position within the song. Over here, we're going to have volume control. Down here, of course, is our playlist that we currently have loaded. At the bottom, we have the ability to come in and, open up what songs are we going to load into our playlist, and we'll be able to select multiple songs and add them in at one time, which is going to be cool. And, of course, the ability to subtract songs out of our playlist. Over here, things like repeat the playlist, shuffle the playlist, repeat the song. Moving over, let's open up an M3U file. How cool is that? And also save out an M3U file. And tempo that I talked about just a second ago. We also want to make sure in the development of this application that we start taking into account things like sizability. As opposed to locking the application to a particular size, we want you guys to really start adding that nice touch on an application where if a user goes in there and says, man, I wish this was a little bit bigger because some of the text is getting cut off, that they can resize it and the application resizes properly. As you can see here, all of our controls are holding up nicely, and that's really cool. Now, we don't have the sound system configured right now so that if we were to play a song, that song is going to automatically be picked up. So I'm grabbing a pair of headphones. Boy, am I doing this the cheapest way possible. And I'm going to put these headphones up to my mic just to show you guys. I can come in here and play a song, so I'm just going to double-click on it. And hopefully you guys can hear that. It's going to be kind of faint, but it's now playing. I can come in here and I can drag. Simple enough. And then I have the ability to control my pitch. And then, of course, I can pause, continue playing it, change my volume, jump to another song. That's going to be let me find one that's a little noisier. There we go. And, of course, we have the ability to maximize and to restore. So there you guys go. Let me go ahead and move these headphones out of the way. Hopefully you were able to hear that okay. But that's what we're going for. Now, in writing this, it's a bit involved, right, Logan?
Well, there's a lot of features there. There's a lot of functionality to add.
There really is. And for someone who's a skilled programmer, this is a very simple application. Not a problem at all.
Right. Nothing gets deep at all. The most complex thing we do in the entire thing is a couple of simple loops.
Exactly. But the coolest thing that we've done so far with the Delphi Training Series has been take those that are complete beginners to programming and get them up and running and writing things like Flea, an actual game that's playable. And now we're going to do a full MP3 player. That's some pretty cool stuff. So because to a beginner this is a bit more sophisticated, we need to slow down, break things up, and make it easy to understand. So let's get started. Here's what we're going to do. This video is going to focus on variables. What they are, even variables in itself can get quite involved. We're going to keep this as a very simple overview so that people have an understanding as to what's going on. And that'll wrap this video up. The next video, we're going to take a look at procedures and functions so that we can start modularizing our code a little bit. From there, we're going to get into writing a very simple MP3 player. In fact, it'll kind of become the guts of this entire application. And then a few videos after that, each one will slowly add more and more of the functionality that you guys have here. And once we're done, you'll have a full MP3 player and a pretty strong understanding of how to go in and add even more features. Wouldn't you agree, Logan?
Yeah, so once you've got this done, Pat, you can pretty much go and look through any of your favorite music players and start to look at features you'd want to add for yourself to make it usable as your own system, your own player.
Absolutely. Okay, so we can go ahead and close this out now that you guys know where we're headed. And where do we want to begin? Well, with variables, there's 4 things that you're going to need to understand as a complete beginner. First of all, what is a variable? Second, why do you need them? Third, what types are there? Fourth, how do we use them? And that breaks down into several different things. How do we declare a variable? How are they initialized or a data is assigned into one? How do we access them? And we also need to be aware of scope, because you can't always see a variable. And also, what happens when we have data mismatches, variables that don't match other variables, but you need for them too. So we'll talk about some of those things. Again, we're not going to get super deep because a variable lecture could easily turn into multiple hours if you want it to get really, really deep.
It could turn into a dedicated course if you want to take it far enough.
Oh, for sure. As a matter of fact, before we really get started with the meat of this particular video, let's talk just about that for a second. I was talking with Logan yesterday about, how we were going to go about teaching and what types of variables we were going to teach to begin with. And, start talking about, an integer and a short int and a long int and things like that. And then we start our discussion just kind of moved from there over to, is it a signed integer? Is it an unsigned byte? All right. Well, now they need to understand what a byte is, and they need to understand what a bit is, and, how's it signed or unsigned? Whoa, okay, stop. So before things got out of control, I decided that perhaps a little bit later on, we'll take a look at memory at a lower level. And when we get into the debugger and things like that, and show you guys exactly what's happening. But I want to keep this as high level as possible right now so that we really don't lose our beginners. In fact, Logan, right now, start talking about signed and unsigned and stuff like that. I'm sure some of our complete beginners out there started sweating a little. We don't want that to happen. We really want to keep this simple. Okay, so with that out of the way, we're not going to get that low level, but we do plan to at some point in the future once everybody's very comfortable with working with variables. Now, let's go back to that list of 4 things that you kind of need to understand to have a good grasp of variables. The very first thing is, what are they? Well, a variable is nothing more than a location in memory. Everybody knows what memory is, right? Come on, your computer's got 1 gig of memory, 512 megs, 2 gigs. It's just an area in memory that has been assigned to you, to your application, to store some sort of data in. It's that easy. And we have an alias, if you will, that allows us quick access to that particular location so that we can put information in and we can pull information out. But that's simple as that, right, Logan?
Right. And the key here with the simple types of data is it is just a place.
That's it.
Just a container for data.
That's right. Now, when storing data in that container, as Logan just said, it's very important that you understand what type of data you plan to store. That's very important. You guys have already gotten a little taste of this as we worked our way through the flea game. We can deal with numbers. We can deal with text. There's all sorts of different things. We can deal with logical conditions such as it's true or it's false. And then there's even more things we can deal with. I can start throwing real fancy words out like sets and enumerations, arrays, records, etc. What I want to do is I want to focus on numeric data types, text, and logical data types in this video. And then we can start growing on that a little bit later, but everybody's going to have an understanding as to what, a variable is, and it'll be very easy to add on to it. So let's start out first with numeric. Now, even a numeric type breaks down. We have whole numbers. We have floating point numbers. What's a whole number? 0, 1, 2, 3. Notice there's no decimal in there. Floating point numbers? Well, we have a decimal in there, and it's called floating point, a real simple, cheesy way to sum it up, because the decimal point floats around. You could have 2.3, or you could have 0.23. Ooh, look at the decimal. It's floated around. It's moved. Or we can have 123.658. There's all sorts of ways that decimal can be. So, do you want to deal with a whole number or do you need to deal with a decimal number? That's something that you really need to understand when you start working with numbers. And again, the data type thing is so important because if we put the number 1 into a text data type, it's not truly a number 1, is it, Logan?
No, the data actually differs because to represent the number 1 in text, you have to look at which character, and then that character has a number, which is a different number other than the number that you're looking at. So.
Right. And a good example for this is when we were dealing with Flea, if you guys remember, we had a level. And the level was represented by a label. And we were able to update the caption by saying that the level.caption : equals 1. And so that displayed level 1. But when we went to increment the level, when we changed to the next level up, we couldn't just take the caption and say add 1 to it. That wouldn't work. We had to store that level number in the tag of that label also.
And then after that, we couldn't take the caption and set the caption to the tag because caption and tag were still 2 different data types. You couldn't set the text caption to the numeric tag. It wouldn't allow it. That's why we had to do some converting.
Exactly. So if you want to start doing mathematics on numbers, you need to make sure that the data that you're storing is truly a number and not text. And if it's text, it's not necessarily a problem. You're just going to need to convert it, and that's where Logan just mentioned a second ago. Or it could get
confusing. Some of the things that look like mathematic operations won't work in a mathematic fashion if you're working on text.
Precisely. Now let's go ahead, Logan, and we're going to start a new application. But instead of doing a VCL application, we're going to do something a little different. We're going to create a very simple console app. So let's go ahead and start one real quick.
All right, well, we can go create a new item, go to console application, and there's our application.
Ooh. Now, what is a console app? Well, come on, guys. You guys are familiar with, like, DOS or command-based.
Or you've run things that have to be run from the Windows command prompt.
Yeah, it's a command app, basically. And so just think of it as you're going to have, like, a DOS-style window that's going to pop up, and we can spit information out at you. Very light program, if you will. And this is going to, as you can see already, give us a very simple template here for our application itself.
It cleans up the view. Since we have some very simple lines of code we need to demonstrate, we don't want a lot of other things getting in the way so you get lost scrolling the page just to look at one line.
Precisely. Now, what we're going to do in our little examples here is we are going to start out by taking a look at integers, which is, as I said a few minutes ago, it's a whole number, 0, 1, 2, 3, and it can go negative as well, -1, -15, but there's no decimals involved. Let me jump over here real quick and pull up our whiteboard, and here's how I'm going to kind of represent this entire thing. I'm going to draw little boxes over here, and these boxes are going to represent memory. So we're going to write a real simple program that's going to define some places in memory to store some information. In fact, we're going to define 3 variables. So I'm going to represent these as boxes or containers, as Logan said just a second ago. And we're going to give these guys all a name as well. We're going to call it A. We're going to give another variable the name B. And we'll call another one total. Like such. Now, what's going to happen is in our application, we need to define or declare these variables. And we'll do that. Let's go ahead and jump back over real quick, Logan, into Turbo Delphi. And let's go ahead and declare the variables. This is telling Delphi we need to allot 3 areas in memory to store information.
Right, so this is back into the world of Pascal here, where we're going to have to tell it that we're about to declare variables, and that is done with the var keyword.
So we're using the keyword var, so Delphi knows what's coming next is going to be variable declaration. So let's go ahead and declare A as an integer.
So we've got A is the name we want to use. We follow that with a colon and specify the type. The type, of course, is going to be integer.
Again, very important, because what's really taking place here is there's 2 things. One, when A gets defined, when that memory gets allocated to us in memory, by saying it's an integer, Windows knows how much memory we get to store information in.
Right, that's a key point of a type of data, is how much actual memory is required for this data type.
Exactly. And when working with an integer, as a matter of fact, let's go ahead and...
I guess another more visual way to look at that is your boxes that you store information in can vary in size. You can have a larger box or you can have a smaller box.
Absolutely, for sure. And to jump over here real quick into our whiteboard, an integer is basically going to have a range of negative what is that? 2,147,483,648 through ... 2,147,483,647. That is our range. So the moment that we want to go one further or one greater, we really fall outside the bounds of what we're allowed to hold in the memory area that is assigned for an integer. And this will create all sorts of trouble, right, Logan?
Right. It can vary. It depends on exactly what the compiler is doing that day, what mood it's in, or what settings you've set.
Well, it could come back and simply give you an error and tell you that we have an out of bounds area. We could roll over, and so now our number is going to represent something completely wrong, completely different than what we're expecting. So obviously, you need to think when you start defining variables. Right now, it's not going to be a real problem, but as you start writing more complex applications and number crunching becomes an issue, like let's say with a really sophisticated game, speed becomes an issue, things like that, you really need to think about how much memory do you really need to allocate for a piece of information that you need to hold. Here's a really quick example. Let's say the level in the game Flea. I don't know. What's the highest you ever got to, Logan?
I don't know, 13.
Level 13. And I got to level 26. No, of course I'm lying. I got to probably level 12 or so. Now, what are the odds someone's going to get to level 25?
Very, very little.
Very little. Or how about level 100?
Level 100? That, yeah,
They
I
are
don't know,
godlike.
The monster would almost be jumping on top of you every move at that point.
Exactly.
So, I mean, I would say incredibly unlikely. It might not even be possible.
So what's the possibility of actually ending up on level 2 billion? It's not going to happen.
Because if you think about it in a different way, we had the amount that the monster moved being that number multiplied by, 8 or something like that?
Exactly.
So is he going to jump you don't have that many pixels on your screen by a long shot. I mean,
he just jumps into the next state over. Yeah, he's gone. So, yeah, that's not going to happen. So would you really want to store your level in an integer type variable? Well, first of all, this goes negative. Is our level ever going to go negative? No. So that's the first thing. An integer is not even going to be something we would be interested in. But it is a whole number because we can't be in level 5.8, right? I mean, that'd be kind of odd.
It's just a weird concept to think of for a game like this.
So there are other types of variables that we can have that deal with whole numbers outside of just integer, even though we're going to be focusing on integer dealing with whole numbers here. I wanted to point this out real quick. Some examples would be we have a short int, which would allow us to go a number negative 128 all the way up to 127. Much better. We're not using near as much memory now. But even with this,
we're going negative for no reason. It's like we're taking half of our range and using it for part of the range we'll never use.
Exactly. So that's not needed. So, another type. So this right here, by the way, just to write these down. Now, I know, guys, I'm kind of rambling on a second, but that's the beauty of these videos. I can ramble all day, and hopefully you guys are getting something out of it. So this is a short int. Well, another type that we have available is a byte. A good old byte, 8 bits. And a byte has a range of 0 through 255. Again, later on, guys, I'm going to give you guys a very low-level lecture on memory, bytes, bits, and all that good stuff, and show you exactly how 0 to 255 works. But for now, look at that. Wouldn't this work much better for storing what level we're on, as opposed to something like an integer where look how much memory we're using up there?
Right, it starts right next to the level that you begin at, 1.
Exactly.
So now you're not missing a whole 128 units of range. You're starting right at the start of a byte, and you can use the entire range of a byte as possible levels, because they're going to advance. You could, in theory, reach level 255, still highly unlikely, but then you're using the entire range of the byte instead of half of the range if it was a short int.
Precisely. Now, if you're watching this right now, panicking, oh man, well I got to know all these different variable types, and how am I going to know what type to... Don't worry about it. Relax. Because right now, with the applications we're writing, just using integers is fine. Yes, it's going to look like a lot of wasted memory space, and it is wasted memory space. But in the grand scheme of things, It's not a big deal at the moment. We're not dealing with an application where memory is critical, memory management and memory usage, or speed is critical. Agreed, Logan?
Right. In this case, since, we don't have to worry. We could use integers all day long in the apps we've created so far because we've always hand-picked individual variables or individual types of things we need to store.
Exactly.
Meaning we never have a range where you could possibly load the entire hard drive's worth of files for some reason or count the entire hard drive's worth of files.
Exactly.
We've always had a handful. We've by hand gone and made maybe 3 things in our app.
So we have multiple gigs here, don't we?
Yeah. So, looking at that, we have
2 gigs?
Yeah, some of you might be familiar with some apps that have a 2 gigabyte limit in different regards, maybe a file transfer app or any other app that deals with files.
Mm-hmm.
You've almost certainly had to have run into the 2 gig file limit at some point.
Exactly.
And that's what you're looking at there, 2 billion.
Yeah, 2 gigs.
Range. So, yeah.
So, yeah, all right. So, now let me go ahead and just kind of draw a nice little line like this and one over this way. So that was just talking about some of the different variable types that we have for holding whole numbers, but the idea of showing you that we have a different size container, as Logan said a second ago. So let's go ahead. We're, again, just focusing at the moment on integers only. Let's go ahead and jump back over into Delphi real quick and continue with our A, B, and total. Okay, so right now he has defined one, A, and it is of type integer. Okay, let's create B.
Right, so B will also be an integer. Wow. Yeah, back to typing. So it takes me a second to warm up to the idea of typing things again.
And then total. And total is also an integer. Okay, so he has defined 3 integers. Now you'll notice we have between begin and end, you'll notice this open curly brace and closing curly brace. That's how you can do multiple lines of comments. You guys haven't seen that yet. Up to this point, you've only seen the 2 / just to do a single line comment. I just wanted to point out that it's green and it is indeed a comment. But we're just going to take that out because it's just a thing saying, hey, insert your code here for your application. So at this point, we have got 3 variables defined. If I jump back over here to Photoshop, when we run the application, now what's happening is these 3 variables now exist in memory. But of course, for us to get to those locations, we don't have to remember some really complicated memory address. All we have to remember is A, B, and total. Now, let's go ahead and jump back over here into Delphi. And now let's look at the next thing. We've seen what they are. And basically, what do we do with them? Well, we need to store information in them. Well, how do we store information in them? Well, you guys have seen us use the assignment operator several times with some of the applications we've written up to this point. Well, let's do an assignment operator with a variable. Let's put some information in A. Like, let's say we wanted to store the number 5 in A.
Well, we could say that A is equal to 5.
5. And some people read that := as gets. So you could read the line as A gets 5. But what it means in the end is that 5 is assigned into A. All right, let's go to the next line, and let's put 6 in B.
So we could say B equals 6.
Okay, and then let's go to the next line and demonstrate how we can then assign something a little bit more involved than like just a number. We can actually assign data that's in other variables to a variable. So let's say total : and let's say A plus B.
Ooh, so we're doing an operation and storing the result.
Oh, yeah. So now we're doing all sorts of interesting things. In this particular case, what's on the right is going to happen first, and the result of that is going to be put into total. Now, let's go ahead real quick and jump back over here into Photoshop. And let's see what we had. We had A : = 5. We had B : = 6, and then we had total : A plus B. Now, as each line gets processed, so this arrow says we're processing this line. Here's what happens. A : = 5. A 5 is stored in that memory location. It's actually in your memory on that fancy 2 gigs of RAM that you bought. All right, so the next line is then processed. B : = 6. Well, a 6 is now stored over here. The next line is processed. Now, when we go to process this line, remember what I said. This side the right side is going to take place first. It's going to be evaluated first. So A, the computer sees what's in A as a 5. So the computer sees that. And the computer sees what's in B as a 6. So it doesn't really see A and B. It actually sees what's in that memory location. So 5 plus 6 gets mathematically added together, and the result, which is 11, is then stored over in total. So we end up with an 11 being stored down here in total. So the result, boom, goes over there. And this one ended here, and this one went over there. So now, let's go ahead and jump back over into Delphi real quick. And what I want to do is on the next line, there is a function that we can call, or a procedure called writeLine. So let's go ahead and use that. And we can writeLine and send total to it. And what that's going to do is that's going to basically print out what is being stored in total at the moment to our command console. Now, let's go ahead and jump down to the next line. What will happen, though, as a matter of fact, if you want to, we can show it. Just F9 it. And there it goes. I don't even know if you guys caught it. It's so fast. It printed it out, but that's the end of the application. So the application closed, and there you go. So we need to find some way to pause the console so that we can see the result that was just printed out. And we can do this by simply using the readLine procedure. So let's just tell it readLine, and that's it. So now if we were to compile and run this again, ta-da, look at that, 11. Simple, huh, Logan?
So yeah, going back to the example, it has worked, and we're just using writeLine to see what's in a variable. In this case, we're looking into total and throwing that out onto the console.
So there you go. Now let's go ahead. At this point, the readLine is just waiting on Logan to hit enter, and the application is now over. Now, the next thing I want to do is talk about, well, what happens if we write data to that memory, one of those memory locations or one of those variables again. And I've seen a lot of beginners here get really, really confused with this whole thing. So let's pull our whiteboard back up. Now you guys have seen that when code executes, it's executing linearly, meaning it's going from here down to here, sequentially down to here. So the next line would get executed next. So what if the very next line was something like A : equals, and we did 10, like that. So then this would be the fourth line to be executed. I've seen a lot of beginners get confused as to what the result of the variable A would be holding after this line gets finished executing. It's really simple. It's not going to be 15. I've seen a lot of people think that the numbers get added for whatever reason. It simply overwrites the contents of this variable with what we put in it. I mean, this is a statement. We are saying, take 10 and put it into A. So after this line right here executes, what happened is up here, this guy's gone, and the result is a 10. Okay? So then if we were to follow that with another total equals, so : equals A plus B, what's going to happen is, well, again, it's going to see A as being a 10 and B still being a 6. We haven't done anything to change what's being stored in B. Okay? And so, with that being the case, we end up with 10 plus 6 giving us a total. So total gets rewritten and it now becomes a funny looking 16. So we can prove this real quick. If we jump back over into Delphi, let's set that up. Let's go ahead and hit, let's do this. Go after the right line and, jump it down a few. Now let's say A : equals 10. Alright. And then jump down to the next and say total : equals A plus B again.
So even just to prove that it's the same thing, we could just copy this entire line and paste it in.
Absolutely. And then let's go ahead and copy and paste the right line total again. So now we should see two lines printed out into the console. The first one should contain 11, and the second one should contain 16 because A got rewritten as a value of 10. B didn't change. It's still 6, and 10 plus 6 is 16. Let's run it.
All right.
And 11 and 16, exactly as we described. So hopefully you guys are kind of starting to get a feel for what's going on. Now, Another thing that you're going to find very useful, and you're going to do it a lot, is to take a variable and add a number to that variable and store that new result in the variable. Wow, that sounds confusing. All right, let's jump back over here to the whiteboard and see if I can find some way to clear that up. Let's get rid of all that mess right there. Let's say we had the variable A, so we'll draw a little box. Let's put an A on top of it so we know that's the name. And so up here, I said A : equals 5, terminator. So that means a 5 got stored in here. Now let's say we had some other fancy lines of code that did some stuff, and then we needed to add something to A. Later on, we could come back in here and say A, which is still equal to 5 because we haven't changed it. So A : equals A plus, I don't know, let's give it 10. And a terminator. Now, remember what I said earlier. This is very important. We have an assignment operation. What is evaluated first? The right-hand side. All right, well, here's the way Delphi is going to see it. What's in A? 5 plus our 10. So it sees this as a 15. And then it simply overwrites what was in A, and so A is no longer a 5. A now becomes 15 after that line is executed. Is that pretty clear, Logan?
Right. As a matter of fact, going back to your earlier example, what you pointed out was that when you assign a variable, that variable gets completely overwritten. There's no automatic adding that takes place. So
exactly.
If you had 5 and now you set it to 10, you simply overwrite it to 10. You don't add or anything.
Right.
But if you want it, it's possible to get that effect of adding. It's just you have to do the adding. You have to instruct it that you want to add.
You have to do it this way right here. And so, I mean, it really is simple. If you're having a little bit of a hard time understanding what's going on right now, it's only because you're most likely making this too complicated in your head. It really is as simple as it looks. It's an assignment operation, as we see right here. So simply solve what's on the right-hand side first. It's almost like super simple algebra in a way. A plus 10. Well, we already know what's in A. We don't have to solve for A. We know what's in A. And it's 5. So 5 plus 10 is 15. Then we put the result into the left-hand side variable. So A becomes 15, as seen here.
I think the only last thing that I noticed looking at that is just keep in mind that you don't overwrite the variable until you assign something to it, until you use :equals. The part on the right, the A plus 10, that by itself won't overwrite A.
That's right.
You're using A, but you're not writing to it. It's only when the assignment comes in that you're assigning. So you don't have to worry about A plus 10 immediately messing it up and then adding A again when you assign it.
Exactly.
It's when you... Well,
yeah, exactly. Man. It's that it really is that simple. Where Logan was talking about using an example to back up what he was saying is if we did something like form 1 dot width, and we said : equals A, and we had stored something in that. Well, that's just simply saying now we're not overwriting what's in A right here. We're simply taking that value and putting it over here. So the form 1's width becomes A. In this particular case, the width would be 15 pixels wide, which would be a little bit too narrow for us. But that is an example of actually using the variable, but we're not assigning something to it.
Right, and then one last thing to point out is you could do something like form.width equals A plus 10. Mm-hmm. And you would have A plus 10, right? Yeah, you go ahead.
How about this? We'll make this where it worked for real. I mean, it would work for real, obviously, but now it's going to be, you'll have 115 pixel wide form.
And width. And then to go back to my point, you wouldn't be affecting A in this case. You never told it to assign anything to A. So you could use A to have A plus 100 be 115, store that in width. So now width is 115, but A is left unchanged. A is still 15.
Exactly. The only time A changes is when there's some sort of assignment that's being done, or later on when we get into functions and all that have the ability to change. But don't worry about that right now. Assignment. That's how we change it. So let's go ahead and give this example, the one right here, where we're going in there and we are simply using what's in it and then taking the result and putting it back in there. So let's jump back over to Delphi real quick. And let's, jump down, hit enter once, and let's do A colon equals, I don't know, A plus, and give it 5 or something. All right, and then let's say, let's just do this. Next line, just say right line and spit out A. So now, what's going to be an A? All right, so walking through this, let me hunt for a mouse over here real quick. So this first part right here, A gets assigned a 5, B gets assigned a 6, and then the next line, total gets assigned 11, because that's the two added together, and that's what gets printed out to our console. Then coming back through again, A gets 10 in it. 5 is no longer there. It's been overwritten completely. So then total takes and adds A and B, which is 10 and 6, and we spit out a 16. And then we'll come down here and we say, all right, now in A, what I want to do is take whatever is currently in A, which is 10, add 5 to it. We now have 15. Store that over in here. Print out 15. So we should see, let me get it right here. 11. We should see 16. And then we should see 15. So let's go ahead and run that real quick.
And I accidentally left the program running.
So let's go ahead and close program and run it.
And
there we go. 11, 16, and 15. Exactly like I described. Beautiful, beautiful, beautiful. So, Logan, anything you want to add on top of all of this, or you want to start looking at another data type for a minute?
I think that covers it. We've got assignment and usage of a variable in different cases. So
okay, beautiful.
Looks good to me.
The key thing here is, the key thing is you must, in Delphi, you must declare a variable. You cannot go in there and just start randomly using an undeclared variable at any given time. For those of you that are coming from other scripting languages or other programming languages, you may have been dealing with a language that allows you to do that. Delphi does not. It's very strict. You must define the variable type before you use it. Okay? So, all right, Logan, now that we've taken a look at integers, what happens if we need to start dealing with floating point numbers, decimals? So let's, the two we're going to focus on, single and double. And now the idea, of course, is a single is going to hold a certain amount of positions, if you will, after the decimal, and the double is going to hold even more, giving you a more precise number. I'm trying to be very careful dancing around here because this can get complex. So let's go ahead and make some variables.
All right. Do you want to start a new app?
We can start, or you can just kill out those vars, and yeah, that works. Beautiful. All right, so let's just do some simple assignments. So make like S as a single and D as a double. Ooh, and you know what, Logan? Here's a great one that people are probably wondering. We've used A, we've used B, we used total, now we've used S and D. The names of variables. Wow, that's interesting. How do we know what kind of name we can use? Well, you can get away with using pretty much any name you want as long as it's not...
There is no name or symbol that's tied directly or required for a certain type of data.
We can't use keywords, obviously.
Right. Other programming languages, there's some that take in a certain symbol. I've even heard of older ones that take in the prefix name and use that as the actual type.
Right.
In Pascal, no, the name is pretty much just a name. You could have my float and have that be an integer and not a float. So you want to be careful with naming it. You can name things that verbosely. You could say my float or my float and have it be a single or a double.
Now the big thing though is obviously we can't put spaces in, like we can't say my space float.
There's other constraints. You have to use only alphanumeric characters or certain ways it has to begin.
Yeah, but like you're not going to go in there and put quotes and stuff like that in a variable name.
Right.
So let's just keep it simple right now. Just names, guys. It can have letters and numbers, and the idea is generally to make it descriptive. In our case, we're just keeping these super short right now. S because it's a single. Yeah, whatever. D because it's a double. It's just for quick example purposes. But when we start coding things, like when we go back to Flea, we're going to make the variables make a little bit more sense, because if we just had a variable that was going to contain what level you're currently in and we called that X, that would be kind of confusing to someone who came in behind you later and looked at your source code and they're like, what the heck is X?
Or if you just start with A and name all of your variables A, B, C.
Oh, yeah, what a nightmare.
And it's like, well, I happened to be on G when we were doing the level, so that's what it was.
I mean, it would make so much more sense to have the variable that's going to contain what level you're on be called something like level. You see what I'm saying? Or if you had lives, you could have a variable called lives. You want to keep it, the name related to what it's being used for. All right, good enough. So now we've created two variables, a single and a double, and these obviously are bigger memory locations because they now have the capability of holding a decimal point that has a series of numbers that goes on out from the decimal point itself. The single not allowing near as much as the double. Let's go ahead and put something like 5.6 in each of those.
So we'll set S to be 5.6. We'll also set D to be equal to 5.6.
Okay.
So storing the same values.
Now let's have a little fun. Let's write both of those out to the console.
So then two write lines, one for S and one for D.
Now we're going to get better accuracy with a double. Agreed?
Yes, most definitely. Like you were saying, it's a larger container. You have more information that can be part of that.
Because, dealing with decimal, a computer, when you really, man, I promised I wasn't going to do this, but I'm going to do it anyways. I'm going to do just a piece of it. When you really get down to it, what does a computer contain? When it comes down to memory, it's bits, right? It's like, here's 1, 2, 3, 4, 5, 6, 7, 8. 6, 7, 8. And each of these little boxes is called a bit. 8 bits makes up a byte. Ha! Told you I'd get it in one way or the other. No, just kidding. And basically, the information that's stored in here is a 1 or a 0. It really is that simple. So here is some memory that is stored in your computer right at this very moment. Ta-da! Where's the decimal point?
There isn't. If you look at it at this level, while this is the actual data that's stored in the hardware of your computer, that data is simple. It's simple for the mechanics of a computer. For the computer to be able to work, it's basically a big series of gates that are on and off.
Yeah,
that's where you get the concept of bits. A bit isn't even so much a fact that if you had a microscope, you could see a 1 or a 0.
Sweet.
It's more of blocks or cells within your memory can be in an on state or they can be in an off state.
Exactly.
When we're looking at this in code, we interpret that as a 1 or a 0.
Look at his little charges. Is it charged? It's on. Is it not charged? It's off. Simple enough.
And that's why a computer is binary, is because everything is stored at the most simple level possible, either on or off.
Exactly.
We string lots of on and off signals to make more complex numbers.
Right. So, wow. How do we deal with decimals? Well, it's magic as far as you guys are concerned right now. Later, perhaps we can get into that. But I just wanted you guys to see that as far as at a very low level with a computer, you don't have a decimal point floating there. The number's not stored like 5.6 at a low level in memory. It doesn't work that way. So because of that, watch what's going to happen next. This is kind of the intro.
Yeah? In the going back and forth between ones and zeros and things like numbers and decimals, a loose analogy would be something like Morse code.
Okay.
You accept that longer and shorter has a meaning.
Okay.
And even though you're working in long and short and pause, you can actually pull entire words back out of that.
Absolutely.
A computer is able to do the same thing.
Yep, very good. So check this out. Let's go back over here, and you're going to see where precision becomes kind of interesting in just a second. So if we were to print out S, and then we were to print out what's in D, but they both contain 5.6, let's run it and look at the result. Very interesting. So the single contains 5.5999990463257 to the exponent of 0000, and then our double contains 5.6, all zeros. Very nice. So our double is more precise. Wouldn't you agree, Logan?
Yeah, and what that looks like to me is that a double is closer to how WriteLine is actually handling the data. It's like the single wasn't what WriteLine was expecting, so a single shown as what WriteLine sees it is kind of rounded.
Just like such.
It's missing some information, so it kind of fills in the blanks, and you get a number that's a little bit off.
Oh, but don't let that make you think that, oh, man, that I need to always use a double or even bigger types, because trust me, there are bigger types available. That's not the case. Watch this. We can actually spit back out that 5.6 real quick. If we go to, let's say, the WriteLine. Let's go and close that out for the single. Let's format it. So here we're going to use a basically a function within WriteLine, and we're going to format it to a specific precision after the decimal point.
All right, so this is the format function. It takes in the way you want this item formatted, and then it takes in what are known as the arguments. We're not going to get into arguments right now, of course.
Yeah, this is a monkey see, monkey do part, guys.
So we're going to take in format. We're going to tell it that we're going to be formatting S, and the way we want that formatted is to be %F. As a matter of fact, I'm going to go beyond that. And do you want to specify a precision yet?
Yep, let's go ahead and give it a precision, and let's say just one spot after the decimal, so
right.
0.1.
So let's see if I've got this lined up. It looks like I do. I'm just going to clean this up a little bit. There we go.
And when we run that, check it out. We actually got our 5.6 back out. Not a problem at all. As a matter of fact, if we were to go even further, and let's say that the single contained back up where we assign S, and let's say that it's 5.632. And then we run it again, and we get, precision's at 1. So let's give our precision to 3 now. So 3 places after, and look at that, 5.632.
So we can accurately store that. Here's another interesting thing. If you're running something through format, like let's take this all the way back to the simple 5.6 and take our precision, and leave our precision at 3.
Okay.
So what does this see it as? What comes after 6? With format, we're not just truncating it. We're not just cutting the end off.
All those other numbers we saw earlier.
We're saying if we were to look at this as a precision of 3, what would it look like? It's like, okay. And you can see there that the precision we have available in a single is plenty for storing 3 decimal places.
Plenty.
We have that
without a doubt.
With perfect accuracy after formatting. It's when you look at it in kind of a raw mode with a simple WriteLine and you see all the weird stuff that where it's trying to give you the entire range all at once.
Exactly. So there you go. This is pretty much, Logan, all I wanted to do in regards to dealing with floating point numbers at the moment. Just to show them that we can.
It's weird how in a floating point, or with an integer, we were just dealing with size, and size was how big the number could be.
Right.
The world changes a little bit in floating point, and that is how accurate the number can be.
Exactly. And we have several different types. Like a minute ago, you guys saw when we were talking about integers how we had a short int, and we have a byte, and there's things like words, and int64, and long words. When we start dealing with real numbers or floating point numbers, then we get into things like there's a real 48, a single, a double, an extended, comp, currency, all sorts of things that we can use in regards to different data types. Again, it's kind of like use the right tool for the job. Later on, when you start getting into more complex applications, dealing with more complex numbers and memory management / control. I mean, it just really becomes important that you don't get carried away and use a lot of memory when you don't need it, or you don't give enough precision when you need the precision. But right now, we're not going to be getting into anything like that anytime soon. So now we've taken a look at working with whole numbers and real numbers. Let's go ahead and turn our attention now to some text. Let's start working with characters. And this is where we're going to start dealing with strings.
Okay. Let me erase some of these lines back out. We'll be set up to continue. Okay,
so for strings, let's say that we wanted to use somebody's name, okay? So how about let's do a first name as a string and a last name as a string and then just name as a string.
And just name by itself. Now, and then for formatting reasons, I'm going to do something here. I'm going to just space these out. Okay. That keeps it
cool. All right. So, and formatting, ladies and gentlemen, has become more and more important as we dig deeper and deeper into each of these training videos. We haven't really been smacking you guys hard about that yet, but we will be. Okay. So, let's go ahead and assign, Bob as the first name.
Okay. So that would be...
Once again, in the variable usage, we say the variable name gets, (equals), Bob. Now, here's the key thing here. Check this out. There is a single quote around Bob, the starting and the ending, and that is denoting that it's a string. Here comes a string of characters that we're going to assign into first name. Now, real quick, what I want to do...
Before you jump over, let me just show one other thing. The reason that we need to use something to denote a string is if we had an expression like this, what's to say that Bob couldn't be another variable?
Absolutely.
We had just seen how we were doing total equals A, of course, plus something, but you could basically say total equals A. In this case, first name equals Bob. Bob would be viewed as a variable.
Exactly.
If we put the quotes around it, we're telling it, no, this is data.
Exactly. Now let's show you what that kind of looks like over in memory, a very cheap way, if you will. So let's go ahead and clear all that out. And I'm going to draw our box again, but I'm going to draw our box a little differently. So like such. And how many characters are we storing at the moment? 3. And it's called first name. Awesome. Because these guys are indexed. I can actually come in here and say, give me the first character. And it's going to know that that's the first character. That's the second character. That's the third character. Heck, in a few minutes, Logan, we'll even show them that. That sounds kind of fun. But this is what this is going to look like in memory. Each character is kind of stored in its own little memory spot, and they are all chained together.
So the whole thing is a box. It's just more of a more advanced box.
It's a more advanced box. It's a box that has compartments, if you will. So let's go ahead and jump back over, and let's show how we can then say, let's just go ahead and say name : equals first name. So now we're taking what is currently stored in first name, which is Bob, and we're assigning that into the variable name. So Bob ends up getting stored in 2 different places. So let's go ahead and write whatever is in name out and make sure that it says Bob.
So that looks good to me. And
okay. And there we go. We've got Bob. So let's now continue on after that right line, and let's go ahead and say last name : equals Smith. And now let's do concatenation. So now we're going to introduce you guys to a new concept. And you've already seen this. We did it in the flea game. And we're going to do it here. This is where we're going to do addition, if you will, with strings. And all that really is just append to the end is all we're doing. So first of all, if you don't mind, let me jump over here to the whiteboard real quick. I'll just kind of push the concept. So now we stored Smith, right? So SMITH, like such. A moment of silence. And this is our last name variable. Now, what we want to do is we want to add these 2 together. So we're going to say name : equals, and just for the sake of writing this faster, just pretending I'm writing the entire thing. First name plus last name, like such. Terminator. So again, just let's stipulate that I typed out all of, or wrote out all of first name and all of last name. So now the way this gets handled in memory is now this addition operator means to concatenate, because we're now working with what kind of data? A string. It's not numeric data. If it's numeric data, well, Delphi would know that it needs to add the numbers together mathematically. But we're not working with numbers. Now we are working with characters. So what's going to happen is it's going to take whatever here is at the end and append it to the end of this guy. So what we'll end up with is name is going to look like this. So name is going to be BOBSMITH, just like that. And if we were to get all fancy and show it to you broke down into, there's the variable and then into its compartments, this is exactly what it would look like. So Bob Smith, just like such. Notice there's no space between the names. Logan, let's go and jump back over and write it out and show it to him.
So we just got done.
Name. So let's go ahead and say name equals. And first name plus last name. So again, concatenation. Concatenate last name to first name. And then let's write it out. And let's execute it. And look at that. Bob Smith. So there's definitely a problem. Now, if we wanted to separate the 2 so we didn't have a problem and it looked better, let's go ahead and I'm going to jump back over here to the whiteboard real quick. And I know I'll make this fast because it's not the most fun thing in the world to watch me write all day. What if we did something like this? We know that a string is indicated by using quotes. Just single quotes. So if I said single quotes with just a space between the two, and then plus last name, like such. Oops, jumped a little bit too far. Then what's going to happen is down here where it said Bob Smith, insert it. Actually, let me just do this. Insert it right in there is going to be, well, a space, just like such. So that's not a sad face or unhappy face or whatever. That is a space that I am indicating that exists between the two single quotes. No, that's not ice. Stop it.
It's also not a frog.
And it's not a frog. So what happens now is the data gets completely changed because it's being overwritten, obviously. So we now have the space in there, and S, M, I, T, and we now have the H over here. So that's what it ends up looking like. So let's go ahead and prove that by jumping back over into Delphi and adding a single quote, space, and another one, and then add again. So, look at all this complex concatenation that's going on. How cool is that? Let's go ahead and execute it, and you'll notice that Bob Smith is now fixed. Ta-da!
Because we had to add in the space. Our names contained no spaces whatsoever. So we had to add a space ourselves.
Now, we could have done something like, let's take the space out, so it's just first name plus last name. All right, now let's go ahead and go up to Smith and put a space right before the S. That's going to work just fine. See? Fixed. So go ahead and close it so our beginners can look carefully at it. So again, we're just concatenating whatever's in last name to first name, and since last name begins with a space, it's going to work out beautifully. All right, so now that we've got that in place, let's go ahead and take a look at another type of variable that deals with characters. Let's take a look at a char. So we'll go ahead and define a char. And its keyword is going to be char. And what does it hold? It holds a single character. So let's go down after that right line down there. And put char colon equals, and let's put like Z in it. And then write it out. So again, you'll notice Logan is using the single quotes. So let's go ahead and write out what is in right line C. So we're just going to write C out. Let's run it. And look at that. Z gets written out. Very cool. What happens if you try to put like ZZ in char? ZZ only holds a single character. This is a problem. When Logan tried to compile it, there are errors. Click OK. There's your error. And below we get incompatible types, char and string. And I mentioned incompatible types at the very beginning. What happens when there's a mismatch between two data types? Like what happens if you have a number and you're trying to use it with text? Or in this case, what happens if you're trying to use multiple characters, which is a string, with a char, which is only going to hold a single character? Well, you're going to get an incompatible types or a mismatch of types. So in this particular case, all we can do is put a single character in there. And that character is not limited to a letter. Logan could put a 9 in there if he wanted to. And compile and run that, and you'll notice it's going to work just fine. It's going to print out the 9. It's a single character. It's alphanumeric. He could even put a symbol in there if he wanted to. Here he goes. Da-da-da. And some type of groovy symbol. And hey, look, the symbol even printed out. So you guys get the idea. Now, let's jump back to one more concept before we finally leave strings alone for now. And that is, if I'm going to jump over real quick to the...
Let's set that back.
Okay. I'm going to jump over real quick to the whiteboard. Now, remember earlier I mentioned strings are indexed. So I can say the B is the first character, second character, third character. We can prove this now. I'm going to take what is in first name's first character, and I want to store that over in C, because remember, C is a char. It will hold one character. So that means B should end up over here. So let's go ahead and show you how this is done. Let's jump back into Delphi real quick. Now, after that last right line, let's go ahead and do C colon equals first name. Check this out now. Here it comes. Open square bracket. And let's say 1. Close square bracket and terminate it. Now let's write that out. Now for some of you that are familiar with other scripting languages or programming languages, you may find something similar to this is 0-based. In Delphi, when working with characters like this, it is 1-based, meaning that index 1 points to the very first character. So in Logan Runs, we're going to see a B, And there's B for Bob. So now let's go ahead and close that and change that 1 to a 2.
And if you don't mind, I'm going to erase this example.
Sure.
Just so we keep the output, because we've now got Bob, Bob Smith, Z, and
that's fine.
Everything else. So.
Okay, so there's B. So now let's pull out, instead of the first, let's pull out the second. And now it should be an O. Very nice. And if we change, let's go ahead and change first name to just say name.
So change this out here, you mean?
Yep, just change that to name. And then let me grab whiteboard real quick. So back over in whiteboard, if we wanted to grab out the M right here, that would be 1, 2, 3, 4, 5, 6. Let's see if we can grab it. Let's tell it the index 6 is what's going to be pulled out. All right, give me an M, give me an M. Woo, we have an M. Excellent. So there you guys go. So that is a char, the ability to hold a single character. Simple, eh?
Yeah, you have a char for a single character. You have a string for if you want lots of characters. And if you want to go back in and extract out individual chars out of a string, you can do that.
Yep. And then, of course, there's all sorts of things we can do with strings. You guys have seen we can uppercase them, we can lowercase them, we can reverse them. We can go in a string and search for a series of characters to see if the characters exist. We could say if those characters are found, let's extract a part of it out. We have the ability to do some really cool things. And these are all things that you're going to find yourself needing in applications very soon, actually. So just keep that in mind, and we will introduce those things as they become relevant. So at this point, I want to show them a real quick Boolean.
Yeah, we can do that.
Make something up real quick.
All
so
right.
What is a Boolean? A Boolean is 1, 0, true, false, on, off. It's a toggle state, but in Delphi, it is true or false, period.
So let me go and set.
So he's creating one. It's the name of the variable is B. Again, we can use whatever we want. It's of type Boolean, and try to put a 1 or a 0 in it.
Okay. So we could say B is equal to 0.
And run. There are errors. Incompatible types, Boolean and integer. Again, here we're dealing with a mismatch of data types because 0 is a whole number. It's an integer. So watch this. Let's go ahead and set it to false. So now he puts false in there and he runs it. And not a problem. It works just fine. So if you want to store very simple piece of information, just denoting that something's on or off or true or false, a Boolean is what you'd want to use. That's really as far as we need to go with this right now. As we start diving deeper into it, then we start mixing this with if statements and all, we'll show them how powerful that can be. Again, if you need to store on or off, true or false, yes or no, this is what you'd want to store it in, as opposed to something like an integer, which is going to utilize a lot more memory. Okay? Anything you want to add to that, Logan?
No, it does go back to the whole concept of signals on and off inside a computer, where if you literally used a number and stored the numbers 1 and 0 in them, you're not storing just one cell within memory. You're storing an entire list of numbers that means like 5 or 10 or 2 million.
Exactly.
If you literally just wanted an on-off signal for use in your own code, you can use a Boolean, because now you're not worrying about using a bunch of numbers or ranges or anything. You are presented with something you can use to represent on and off.
Exactly. Okay, beautiful. So that's Booleans, and I think that's everything I wanted to cover right now. Now we're about to hop over into Flea, but before we do that, let me see if I can find my notes over here and jump all the way back to the very beginning as a quick review. All right, so in summation, variables, what are they? It is an area in memory that has been allocated to your application for the storage of data. Simple. Data comes in different flavors. Are you dealing with numbers? And if it's numbers, is it a whole number? Is it a real number with a decimal? Are you dealing with logical conditions like true and false? Are you dealing with text, characters, etc.? So you have to know what kind of data you want to store in that memory location so that when you create the variable, which you do by defining it, which we saw that with the, hang on, let me go ahead and grab I got paper everywhere. Let's grab a mouse real quick, which we already saw. We started the the declaration by first saying var, and then defining it inside where we did B, Boolean. We can also, something else, Logan, we can go ahead and throw at them real quick. Let's pretend that we wanted to create A, B, and C as Boolean. You guys have already seen that when we were declaring multiple variables like A, B, and total near the beginning of this video, that we did them all on separate lines. We don't have to do them all on separate lines. As a matter of fact, go ahead and just redo that integer line. Do A, B, and total again. Let's do it on one line.
So if we wanted... So still assuming that A, B, and total are
all integers. Yeah.
We could say that A, comma, B, comma, total are of type integer.
And terminator. It's that simple. We just simply separate each of them by placing a comma between them. That's how we separate.
I compiled that there. It's kind of complaining that we aren't using them yet, but it did in fact compile. If we run this, there are no problems.
Yep. So again, as long as they're of the same type, just separate them with commas and at the end, colon and the data type, and that works just fine. So I wanted to point that out. So we know we need to declare them. Now, on top of declaration, we saw that how we can assign information in them. We saw that how we can read information back out of them. And that's pretty much it. It's that simple. Now, there's a couple of more things that we need to talk about, and I guess we'll talk about that when we get into the flea code here in about 2 seconds. And that is scope, where they're seen and not seen at, because you create a variable doesn't mean that every place in your program can see that variable. It really depends on where you declare the variable at as to who can see it. Because right now, when we make A, B, and total and we put information in it, as soon as we close our application, A, B, and total is gone. It can't be seen. It's only there when the application runs. And then that's because at the moment they're global to the whole application. But as we start to get more precise in a minute, while the application's running, we can make it so that parts of the application can or cannot see these variables. So with that, let's go ahead and open up our original flea code.
All right, we're done with this. And let's jump into flea, and here is our flea project.
Okay.
So I can close out the application unit and just go to the main unit.
Okay, now the things that we need to change in here. We're going to need to change level. We're going to need to change score. We're going to need to change high score. And we're going to need to change background. As I said at the beginning of this video, we were using the tag object. As a matter of fact, go ahead and select. So there Logan has selected level. And you'll notice in the object inspector, that's its name, level. And as he goes all the way down to tag, you'll notice how we've got tag set to 1, indicating that the first level is, well, the level you're on when the game begins. We don't want to use tag no more because that's not an elegant way to write an application. You truly want to use a variable to hold information. And that's what we need to do here. So we're going to need to make those changes. Now, where do we define the variables? Let's jump over into our code. Now, it's a fantastic question. We have at the unit level, we have within the class, we have within procedures and functions. People may be going, what is he talking about? Well, you guys saw that Logan started it out by typing a var. And in this particular case, if he wanted to, let's ignore the class and let's jump right down to, there you go. Look at that. We already have a var in place.
In this unit, we already have the var because this form has been made available as a variable.
Wow, Logan, that's kind of interesting. So
does that mean that a class or an object can be referenced as a variable?
Yeah, it does. So we could go right in here and actually just type in level and say it is of type whatever we want its type to be. And our level's not going to get 2 billion in size, right? So we don't need it to represent gig. So we could say our level's going to be a byte. So let's just play with level to begin with.
All right, level will be a byte.
A byte. So again, very small number, very small range, 0 to 255, nothing big. Now, if we compile right now, we've got problems, don't we?
Let's see. As a matter of fact, I think it allowed that on the compile.
Yeah, I think so.
And it allowed it to run. That's interesting.
How groovy is that? Well, it's smart enough to distinguish the difference. Well, what do you know? Okay.
And then that gets back into scope. They're kind of in two different worlds.
They are.
In a sense.
So let's see. How do we want to explain this? First of all, where Logan has placed it at the moment. Let me just grab the mouse for a second.
Sure.
Because this is a lot going to go on here. You'll notice up here we've got our unit main, right? We've got our interfaces, and then we've got our uses, and we've already played with uses a few types. We get down here with type, and this is where we get into our form and all of the different objects that we have on the form at the moment, and then procedures that we have defined. These procedures were defined because they were events. Remember when we clicked on a timer, then came over here into our object inspector, went to events and double clicked on on timer, things like that. Then a procedure was created. Delphi came in here and added this stuff in for us, basically prototyping the procedure that's going to appear down here further. And here's all the procedures as we ended up having to go in and code them. And in the next video, we're going to talk about procedures, and we'll see if we can make this as clear as possible but to understand. But you'll notice with these procedures that every now and then, some of them have a var section of their own. So here is a procedure. This procedure is tform1 dot enemy timer. So basically, every time the enemy's timer fires, this is the code that got executed. And if you guys recall, when we created this code, we told you to just believe us that the intersect rect function would allow us to check if two rectangles were colliding or intersecting with one another. And we had to throw this fancy little section in. There was just no way around it. What do you know? It's a variable. But check this out. The scope of this variable. This variable can only be seen inside the enemy timer's procedure. Meaning that when the form is first created, remember how we did some simple initialization stuff, right? We got the caption, the path of our application. We went ahead and we loaded our start graphic and our HUD standby. So we did some basic initialization stuff. Inside this procedure right here, we cannot see this variable up here because this variable up here is limited in scope to only within this procedure. Now, Logan just added level outside of these procedures up here at the very top, right before implementation. This guy, his scope is within the entire unit here. So if we wanted to, we could come down into the enemy timer procedure and we can access the variable level. We could come down here into the level timer and access level, which we're actually going to do in just a minute. So you guys, does that make sense, Logan?
Right. All scope does is allow you to contain how that's used, and another way to think about it is the fact that if it's part of a procedure or part of an object, that it exists only for the duration of that object or procedure. Meaning on the timer one, what that means is that you only have an overlay variable in existence for the duration of that procedure.
Right.
It's
procedure runs, and once it's done executing, we're done with the procedure for now. The variable data is gone.
Right, and that's also an efficiency standpoint. Is if you had a lot of data you had to work with, and when you're done with the procedure, if you're done with the data, you don't need to have it lying around.
Right.
Just use it and then clean it up when we're done.
Now that may seem a bit confusing because you don't have a concept as to exactly what procedures are. I mean, you have an idea right now, but in the next video, we'll make that a bit clearer and we'll come back to variables and we'll make sure we explain exactly how that's working each time we push one of these and execute it and then we release it. But that is the key thing, is that if you define a variable inside a procedure, it's only being used in this procedure. Nobody else can see it. So you've seen var being used right before begin within a procedure. You've seen var being used before we begin implementation of all of our source. There's another place that we can create these variables as well, right, Logan?
Right. We've got the private and public sections of the class for the form itself.
Right. And this is when we start getting into object-oriented programming. And this is a variable that will exist when the object is created. And I don't expect you guys to understand that. But here we define a class of type tform, and basically when this form is created, the variable would then exist within that object, within that form. And if we were to turn around and create another object from this class, we would have another instance of that variable as well. So if we wanted to, we could declare our variables inside private or public here. Now as far as why private or why public, that goes way beyond the scope, if you will, of this particular video, because that means you have to have a bit of a better understanding in regards to object creation and all. So let's go ahead, and with that being said, let's go ahead and put our variables in place.
Okay, we've got level we want to store as a byte. Now again, to reiterate, the things that we're going to be storing as variables will be level, background, score, and high score.
Right.
Now, level we already talked about, and we've decided to use a byte because we don't anticipate anyone reaching level 255.
Unless they're godlike.
And if they do, then they can enjoy a nice little old arcade-style glitch. Those are always fun.
And then background is another piece of information that we would never want to get up to. I mean, right now we're using what, like 3 background images at the moment?
Yeah, we've only got three different backgrounds.
So
we've got fewer backgrounds than we do levels.
Exactly.
Because the background only changes every 2 levels.
So we don't need to use an integer type for that. So again, we can go ahead and put a comma here and put a background in. Okay, simple enough. All right, so those will be of type byte. Now we've got to deal with our high score and our score, or score and high score.
Now, score and high score very quickly go over 255. Right off the bat, there's no way we could store those in a byte.
But we also know we're not going to go over 2 billion, so again, unless you're godlike.
So we will say that score and, what was this one, high score, are both integers.
All right. So now what we need to do is we need to go through our code and we need to remove where we're using tags and start using variables.
And I think one thing we need to do even before that is clear up our naming between things like level and score, because we had labels that were named level and score.
And interestingly enough, though, it seems like it's not going to give us any problem with that, but I agree we should change it because it would be very confusing otherwise, because at this point you're dealing with a variable called level and we're dealing with an object called level as well.
So we'll clear this up by going into each of our labels here, starting with the level label and changing its name. I'm going to prefix all of these labels with LBL, just following a well-known naming convention. So we'll use LBL level, LBL score, LBL high score.
Okay.
And I'm going to leave game image the same, just because
we're not using a variable called game
that works
image.
for the image itself.
It does.
Instead, the variable we can hold is what background, because the idea is different here. Background is going to be a number this time. We're looking at background not as an image, but as background 1, background 2, and so on.
Exactly. All right, very good. So now we need to go ahead and start changing all of our tags out.
One interesting advantage we got by renaming those is if we were to attempt to compile, the compiler will error at each of the points we need to change because we no longer have labels that are level and so on.
Yeah, because all because it changed the names up at the top, it didn't change it within our code.
So if we look at one example here, let's go down to the enemy timer, or what happens on the whenever the enemy timer.
Yeah, when the enemy timer fires, remember the first thing that happens is the simple AI, which means the enemy is going to track its way towards the player. And how did we do that? Well, basically we determined where the player was, and we used that information to determine where the enemy moved, but we also used the level that you're on to help that out a little bit, right?
Right. As if we go over to the end, we've got level.tag.
Made it go a little bit faster, a little bit slower over there.
And what I was talking about before is if we wanted another way of finding this, we could just attempt to compile. And our first error is going to happen when we started trying to use tag, because now level is no longer a label. Level is a variable of type integer. Integer has no such thing as .tag.
Right.
So what we can do here is level itself is now a number. We can simply disregard the tag part of it, and if we compile, that's no longer a problem. It moves on to the next line. So we can go through each of these, remove the .tag, and now that should take care of that section.
Okay.
So we can pretty much just go through and
just compile and let it find where. All right. So the next problem is in what procedure are we?
We are still in the enemy timer.
Okay.
This is in the score checking when we go to see if we've made a high score or not. Again, both score and high score are now integer variables, so it's a simple matter of disregarding the tag that they don't have. So we take out our tag, and now in this one we're talking to the label itself because we're trying to access caption. We do still want to keep our labels in action. We want them to keep working.
Right.
So I'm going to change this guy in reference to the label, not the variable.
That's right, because just a second ago, Logan changed the name of high score, that label, to LBL high score.
So to finish this off, we can jump over to highscore.tag. This time we're talking to the variable version of high score. So we say that the labels caption is set to the string equivalent of our number stored in high score.
So high score, remember, is an integer. It's holding a current numeric value. There it is. And we still need to convert it. Go ahead and highlight that into string. We still need to convert it to a string to store it in the caption of the label high score.
All right, so I think that's that for that part of the procedure. As a matter of fact, that's it for the whole procedure. Now we've moved into the level timer.
Okay.
And we're back to looking at level. So here we're advancing what level we're on. So we simply remove the tag part and say that level is equal to level plus 1. So just advance the level variable.
Right, and obviously on the next line we need to change that because, again, here we are using caption, so that's the actual object, so it needs to be LBL level caption.
And then on here, here's back to the number level, so I just take the tag out and we're back to the variable level.
Cool.
Now, below that we've got, again, a check on level.tag, so we just want to go look at level. And now we're getting into game image. Game image as an object is left alone. The part that's changing here is the fact that we're no longer using the tag of game image. Instead, any case where we would use game image.tag, that will be replaced with background. And same here. And okay, I'm going to get lazy.
Copy and paste.
So there we've got, if we happen to loop around, if we exceed 3, go back to 1. And this game image is entirely left alone. That is still the image.
Still functions just fine.
But one last place is if we scroll over a little bit, we're using the number that is in gameimage.tag, and we just change it over to background. So we use the BG based on whatever number background we're on.
Right.
I think that's it for that procedure, so we'll continue on, this time under the score timer. Our score can be referenced as just score, our score variable, and it's going to be equal to the level. So, I mean, that already cleans up the code. We can say that score is equal to score plus level times 8 instead of this.tag, something else.
Exactly, so it's a lot cleaner, easier to read. Of course, there's a caption, so we need to change that to LBL score. And I see a tag at the end, so we need to remove that. Nice.
And continuing.
Now some initialization stuff at the very beginning when they click the start button.
Now, before we get into this, I think it jumped over one thing back up at game image.
Mm-hmm.
And while the game image's picture is fine, we need to start off the background.
Obviously that's not going to pick up because game image still exists, so gameimage.tag is still good.
Yeah, it's still perfectly valid. It's just not used by us. So we'll set something completely irrelevant to one while our background messes up.
Right.
So we set off our background. Now we can move down into things like level. So starting the level, and then this level means the labels level, and its caption, that's fine. Our score is simply score. Our label scores caption is set to 0, and that should do it. So save, compile, and now everything looks good.
Yeah, let's run it and make sure the game plays.
So here's our game. Start still works, level starts at 1, score starts to count up, and we've got a high score recorded, high score acknowledged.
So die real quick.
And this was not a high score.
And again.
And all these times level is restarting back at 1.
Good. Score is restarting as well. And you know, and our background's changing.
So backgrounds are working. And so yeah, I mean that's everything I can think of as far as testing.
And loop back around, here it comes. And perfect.
So all functionality is still as it was. It's just now we have changed everything over to use variables to hold data instead of sneaking it into various objects that exist on our form.
All right, so that's now putting variables into use in the Flea game. So now that you guys have seen them in action, the only thing that may be really confusing at the moment is the whole idea of scope. Don't worry about scope at the moment. It's going to slowly become more and more clear, especially after the next video when we start talking about procedures and functions. But outside of that, in regards to how much memory do you need, don't worry about that at the moment. That's going to become much better understood as you get more and more advanced with your coding abilities and an understanding of what's happening with the computer itself as you write these applications.
Right. If you were just starting out and you had no idea what you wanted to use for each of these types,
just use
had you used integer for all of these, there would have been absolutely no problems, and there wouldn't have really even been much of an issue with performance, because we're only talking about 4 additional bytes per number that you're storing. So you're going to run out of time. You're probably going to reach the end of your life before you type enough variables by hand to use all of the memory in your computer.
Agreed. So again, it doesn't become really important until we start getting into much more sophisticated number crunching type applications. So, Logan, I think we have successfully taken our first step towards our new MP3 player. We're now capable of using some simple variables in it. Let's go ahead and bring this video to a close, and in the next one we will start them with procedures and functions. Thanks a lot, guys.